We can also have vertical stretching and shrinking, and that's going to be multiplying by a number. So if the number we multiply by is greater than 1 on the outside, we are going to stretch our graph vertically. It's almost like taking, like, I don't know if they make silly putty anymore, but like maybe gum, right? And you pull it apart, you're stretching it. If it is a fraction between 0 and 1, it is going to shrink the graph vertically. So it's almost like somebody stepped on our graph and it gets squashed. Now with parabolas, it almost looks like they get wider or narrower, but think of it really as stretching. So if you were to make your hands like over your head, make a parabola, almost like you're doing the YMCA. If someone were to take your hands and pull them further up, you would get that narrower shape. You would start to, have your arms come a little closer because your hands are stretching higher. If someone were to take your hands and start to push them down back towards your body, then you would start to get wider as your arms kind of moved outside. But what's happening is that you're really stretching up or squishing down, stretching and shrinking. All right, so in this one, we again have that parent function. We have 3x squared. We know it's a parabola because of the little 2 there, but the 3 is going to do something for us because 3 is greater than 1. This is going to be a stretch. And what we mean by stretch is that we're multiplying all of the values, all of the y values by 3. So all y values by 3. And what I mean by that is in your x comma y points. Multiply all of the y values by 3. So like this is the point 0, 0. I would multiply the y value by 3. That's going to give me, well, still 0, 0. That one's kind of boring. But this point right here I have is 1, 1. I'm going to multiply the y value by 3, so that new point is going to become 1, 3. This point right here is 2, 4. I'm going to multiply that by 3, and that's going to become 2, 12, which is way off my page, somewhere up here. And the same would happen on the left, though we know a parabola is mirror image, so I don't have to do a whole lot of guesswork there. So every point has been stretched up. Every one of those points. This one, whoops, let me do a different color. This point right here became that point. We multiplied the y by 3. Same thing here. This point right here became this point. This point right here became this point. This point became this one, and well, 0, 0 does not change. Okay. Same kind of concept here, but instead it's going to be a vertical shrink. And instead of it getting taller, it's going to get shorter. We're still going to multiply because we have that fraction, which is similar to dividing. So we'll multiply our y values, values by a third. Again, when we say multiply, what we mean is we're multiplying the y from the x comma y coordinates. So, 0 is not going to change at all. It's still going to stay 0, 0. When I multiply that 1 by the 1/3, we're going to get 1 1/3, which is about here-ish. When I multiply 4 by the 1/3, we're going to get 1 and 1/3, or 4/3. So 1 and 1/3 is about here. Let's see, the next point we had was 3, 9. And when we multiply 9 by a third, we're going to get 3. So 3, 3. And we could keep going, but you kind of get the idea already. It looks like every one of these points has been squashed down. Okay. All right. We can use the graph of our parent function to sketch too, when we're given all of this extra information. So in this case, sometimes we'll see this 1 in the front. Sometimes we'll see that 1 at the end. It means the exact same thing. So if you're more comfortable writing it this way, feel free, but it means the same thing. It does not make a difference. Think of this as one term and this is another, so I can move them around as long as their symbol, their plus or minus, stays with them. This really has a lot to do with how you're going to see your notation when you get to the trigonometry portion in pre-calc, really because it's less messy when we start putting in the more complicated equations. But the same sort of things are going to happen here. So this 1 is still going to move me up. This 3 is still going to move me right because the minus sign. This negative is still going to reflect in the x-axis, right upside down. And the 2 is still going to stretch every point. Okay. So we want to do a few things here. We want to make sure we're moving right, we're moving up. We want to make sure we're reflecting, and we want to make sure that we are stretching. So if you need to do this in separate parts, absolutely feel free. If not, we can kind of start to do them together. It's up to you. You can always make a table, but this will be a lot quicker in the end to know, what's happening where, especially if you had to do it by hand. So what I like to do first is that reflection. So let's just reflect this thing. So in order to reflect, every point just moves upside down. So that 1 becomes a 1. 2 squared is 4, so I'm down here. And 3 squared is 9, so I'm down here. All right, so all this red one is just the reflection. This is just negative x squared. Oops, that's terrible. There we go. Okay, the next thing I'm going to do is stretch it. I think that'll be the next easiest thing to do. So every y value is going to get multiplied by 2. So, well, that's still 0. Negative 1 times 2 is negative 2. Negative 4 times 2 is negative 8. And the other one is definitely not going to fit on here. Negative 9 times 2 is negative 18. So way down there. All right, so this is negative 2x squared. And then the next thing we want to do is move everything to the right and up. So I'm going to move every one of those green points to the right and then up 1. Right 3 up 1, right 3 up 1, right 3 up 1, 3, 1, and 3, 1. So this blue parabola is my answer. So this is my f of x is equal to negative 2 times x minus 3 squared plus 1. If this were a standardized quiz or a standardized test, if you did have some extra time, you could absolutely go through this. You could FOIL the x minus 3 squared. You could distribute the negative 2. You could add the 1. Then you could go back and do what you did in Algebra 1 where you learned the axis of symmetry. And you could do all that. There's nothing wrong with it. It's just going to take more time. All right. So sometimes we don't just shrink or stretch vertically. We can stretch or shrink horizontally. Think